In Chapter 7, in Section 1 of Chapter 7, we're going to take a look at exponents, and we're going to divide this into two parts. So we're doing lots of things. The product rule for exponents, the zero exponent, quotient rule, negative exponents. They'll mention a little bit about the graphing calculators. And then we'll pick some of this up in the second part here too, where we get into some more challenging items. So again, have your notes ready, pause as needed, and we'll get started. First thing you want to write down is the product rule for exponents. Now, generally, if your bases are the same, and they each have an exponent, and you're multiplying these bases, the product rule, where we're multiplying variables with exponents, is just to add the exponents. So, another thing to keep in mind too, that if you have a letter Y, and there's no exponent there, by convention, there's a 1 there. We just don't write it. And that applies to letters as well. These are some rules. So in doing this one, again, you want to write it down. X to the second, x to the fourth, add your exponents, x to the sixth. Now when I get a little complicated, I'll write them out. But for now, we'll just use this. Try to keep it a little short, but pause as needed. Now remember, there's a 1 by the y, so this will be y to the 7th. And we don't usually put this intermediate step here. Now remember, there's a 1 by the 4, so this will be 4 to the 3rd. And we often are asked to simplify that. 4 to the 3rd is 64. Now here we have 2 to the 3rd times 2 to the 2nd. This is going to be 2 to the 5th. And 2 to the 5th is 32. Now note that our base, which is a -2, is included inside parentheses. And so our bases are the same. This is going to be -2 to the 7th power. Now another item you need to be aware of is when we have a value that is negative inside the parenthesis, raised to an odd exponent number, 7 is odd, that your results will be negative. Now if this were to the 8th power, that is an even power, a negative value inside the parenthesis would be positive. So 2 to the 7th is 128, and then we said it was going to be negative. So if you wrote this out 7 times, an odd number of 7s that are 2s that are negative, you end up with a negative result. For something like this, two things are going on. We have the 2 times 3 to multiply. That's going to be a 6. But now we're going to add our 2 and 9 to get y to the 11th. So there's our 6, y to the 11th. Now here again, we're going to multiply a -3 times a -4, get a positive 12, x to the 3rd, x to the 3rd, we add our exponents, x to the 6th. x to the 6th. Now here, a -6 times a positive 8 will give us a negative 48. Now there's a 1 on the a 1 on this a, so it'll be a to the second. b, 2 plus 3 is b to the fifth. And I like the way they're showing this. Again, write down what you need so you have these as examples. And there's our answer. Now for our next objective, we're looking at the exponent 0. When we have a base, in this case a, to the 0 power, that's going to equal 1. And I will write something out to show you what we're referring to here. So if we had a to the third over a to the third, now you're going to see shortly the rule for something like this. We take this 3 from our denominator, crosses the division bar, the sign of the exponent changes, and this becomes, this 3 across the division bar becomes a negative 3. So this is a to the 0 power. But if we look at that, and I'm going to just do a little erasing here. If we look at this, anything divided by itself, so long as it's not 0, is a 1. So anything divided by itself is a 1. 3 over 3 is a 1. So a to the third over a to the third is a 1. So we said, showing you the technique of moving the exponent up, changing its sign, we get a to the 0. This is going to be 1. So this is the proof of this particular rule here. But there are times when we need to be careful of what they are doing. So for something like this, any base to the 0 power is 1. Now keep in mind, this is a 1 here, so our answer is just 1 times this, or x to the third, or if we add 0 to 3, we still get x to the third here. And they're showing us that this is a 1 times x to the third is x to the third. Now, even though this is negative inside, anything that's the base to a 0 power is 1. Now they're giving us this quotient rule, and again you want to include this in your notes. This might be a quiz question. What is the quotient rule for exponents? And then you would write this, a to the m over a to the n equals, and what are they doing here? They're taking the exponent from the denominator with the same base, crosses the division bar, and then the sign of the exponent changes, and we get this. So this is the rule. Now, remember, in multiplication, if we added, in division, we're going to subtract, which is the opposite of addition. So remember, there's a 1 there that becomes a negative 1, so this is going to be x to the fifth. And we see it illustrated here. Now, y to the second crosses becomes 8 minus 2. This is going to be y to the sixth. Now, here, this is going to be x to the 0 power, or these just cancel out. It's 1 over 1. X to the 0 power, we said, was 1. And there they're actually showing us what I showed before. Repetition never hurts, I don't think. Now, here's a case where there's a couple of things going on. We're going to divide the 3 into the 15 and get 5. 3 goes into 3 once, 3 goes into 15 5 times. But now for the bases here, we're going to bring that 3 up and subtract it from the 15, as they show here. And then we get 5 to the 15 minus 3 is 12. So all of this is pretty easy in some of our basic material. So once again, 2 goes into 20 10 times, or 2 goes into 2 once, 2 goes into 20 10 times. We're going to subtract the 2 from the 10, get x to the 8. Subtract the 3 from the 6, get y to the 3rd. And again, they're showing it to us nicely. And there's our answer. Okay. Now, let me give you some background on this, because this is the rule for negative exponents. And suppose we have, as they're showing here, a to the negative n. And every number is over 1, as we've mentioned a couple of times in the past. So we want our exponent to be positive, and in a sense, there's a 1 out in front of this as well that we don't write. And we don't write this one either. So we want our a to be positive. And the rule, we said, if we have a negative signed exponent and it crosses the division bar, the sign of the exponent just changes. It's negative in the numerator, in the denominator it's going to be positive. And we have to keep our 1 to locate our numerator here. And of course, this is the rule that we have. So if we took this and brought it up to the numerator, it would become this. Okay, so let's do a little work on this. I have to erase that. There we go. So this is 5 to the 1st. Now remember, that's 1 times this, so we can move. We have to keep the 1 up in the numerator. We move this down to the denominator, where it becomes 5 to the 1st. And again, we don't write the 1 usually. Now, we would have to write the negative 1 here, but in the denominator, we wouldn't write it, because we don't write a positive 1 exponent. We know it's there. So again, there's a 1 out in front. We're going to move this down to the denominator, where it becomes this. Again, keep in mind you can't not put the 1 in the numerator, because that's what the proper way to illustrate this. Now here, we're going to do some multiplication of bases that have variables. So the signs are treated. This is going to be a negative 9 and a 7 will give us a negative 2. X to the negative 2. Now we have to keep that negative 2 there initially, but then to make it positive, because they generally don't want negative exponents, we have to move it down to our denominator. Again, crossing this division bar, just change the sign of the exponent. And here are some rules. You can take a moment to read them. Sometimes it's okay to have negative exponents, particularly if we're dealing with scientific notation uses negative exponents. But what we want here are positive exponents. So again, 2 to the negative 5 times 2 to the 8th will give us a solution of 2 to the 3rd when we do this subtraction. And 2 to the 3rd is 8. Now here we're going to simplify, get only positive exponents. Our negative 1 comes up, crosses the division bar, becomes a positive 1 there. So this will be x to the 7th. Now they're using a little different technique, but I like my technique. Cross the division bar, the sign changes. Now again, you want your value to be a positive exponent. So remember, this is 1 times this, so we're going to leave the 1 in the numerator. And bring this negative 5 down here where it becomes a positive 5. So that becomes 1 over 10 to the 3rd. They're doing it a little differently. Here it is. 1 over 10 to the 3rd, which is 1,000. So once again, I'm doing it a little differently, and this way is good too, of course. We have 10 to the negative 5 over 10 to the negative 2. Now there's times 1. So I'm leaving the 1 up there, bringing this down, and I get 10 to the negative 2 plus 5 now. And you could do that mentally if you'd like. And this is 1 over 10 to the 3rd, which is 1 over 1,000. Similar. Again, there's always a little slightly different way you could do things. And then here, we're getting to some complicated things a little bit. I'm going to bring the 2 up, subtract it from the 6. It'll be x to the 4th in the numerator. I'm going to bring the 3 down, and this gives us y to the 2nd when we subtract that 3 from the 5. Now they're doing it slightly different, but that's okay. We get the same answer. And now here, I'll do this one just to show you. So 15 times 2 is going to be 30 over our 3. And then this is going to be x to the 12th up here over x to the 15th. And again, we want to keep our exponents positive. So we're going to cancel this out. Goes once, this goes 10. So we have a 10. But now we're going to take our 12, since this is smaller down here, this will become a negative 12. So in our denominator we have x to the 3rd here. And there we have it. Okay, we're going to pause here. We're not going to particularly be using graphing calculators, but, you know, if you want to look at it, that's fine.